everyone, in this video we are going to teach about chemical bonding and structure. Firstly, we are going to discuss about chemical bond. Chemical bond is some kind of glue that holds atoms together in a molecule or oppositely charged ions. There are three types of bonding. The first one is ionic bonding. It is the attraction between positively charged ions and negatively charged ions. The next one is covalent bonding. It is the attraction between two negatively charged ions. Last but not least is metallic bonding. It is the attraction between a lattice of positive ions and delocalized electrons. Now we are going to discuss about ionic bonding. Ionic bonding is an attraction between positively charged ions and negatively charged ions. We call them cation for positive ions and anions for negative ions. We can easily differentiate the cation and anions through the group in the periodic table. In group 1 to 4, atoms are cation because they are positively charged. In group 5 to 8, the atoms are anions because they are negatively charged. So why does atom have charge? By looking at its electronic configuration, we can see the outer shell that represents the charge of the atom. The electronic configuration of sodium is 2A1. All of the group 1 elements have 1 electron in its outer shell. The positively charged ion gives electrons. It is also known as oxidation, while the negatively charged ion receive electrons. It is known as reduction. The purpose of giving and gaining electrons is to fulfill its outer shell electrons. Sodium chloride will be used as an example. Chlorine needs 1 more electron to have a full outer shell, and sodium has 1 electron. This makes sodium gives away its electron to chloride, causing it to have a full electron shell. Although sodium shares its electron to chloride, sodium still has a full electron shell. Do you know that ionic bonding has high melting point and boiling point because of its strong electrostatic force between them? Moreover, the melting point and boiling point increase when the number of charged atoms increase. The melting point of sodium chloride is 801 degrees Celsius. However, magnesium oxide has a higher melting point, which is 2852 degrees Celsius. It takes a huge amount of energy to break down ionic bonding as a result of its high melting point. Coulomb's law of electrostatic formula states that force is directly proportional to the charge Q1 and Q2 and inversely proportional to the square of distance between them R squared.
So here this is an example of ionic bonding. There are two types, oxidation and reduction. As you can see, this is an example of an oxidation. This is a sodium, and it can lose 1 electron to form Na+. Also, this is magnesium. It can lose 2 electrons to form magnesium 2+. This is an example of a reduction. When chlorine is added with 1 electron, it can produce Cm-.
Ionic bond form giant ionic lattice containing oppositely charged ions, causing ionic compounds to form crystals. Last but not least, ion is not free to move in solid state, so they only conduct electricity in molten state. I think you forget about something. Ionic compounds dissolve in polar solvent water, but not in non-polar solvent hexane. This happens as there is an attraction between ions which pull it off from its lattice pattern to the water molecules. The second topic that is going to be explained is covalent bonding. Covalent bonding is an electrostatic attraction that involves sharing of electrons between atoms. It is usually occurs between nonmetals. Usually we rely on Lewis symbol. It is an outer shell electrons which is represented by a dot. This method is very simple and convenient to be used to represent the outer shells of an element. There are various methods of bonding in covalent bonding. The first one is called single bond. It shares 1 electron with one other. For example, fluorine has 7 electrons. To obtain a noble gas, it needs 1 more electron. When they share each other, each one of the fluorine atom gains 1 more electron. This shared pair can be represented by a line. We can see that there are a total of 6 non-bonding pairs of electrons that can be called as lone pairs and 1 bonding pair of electrons. The second one is called as double bond. It is quite similar with single bond, however this bond shares 2 electrons with each other. For example, oxygen. Oxygen has 6 electrons. To obtain a noble gas, it needs 2 more electrons. When they share with each other, each of the oxygen atom gains 2 more electrons. We can see that there are a total of 4 lone pairs and 2 bonding pair of electrons. The third one is called as triple bond. The bond shares 3 electrons with each other. For example, nitrogen. Nitrogen has 5 electrons. To obtain a noble gas, it needs 3 more electrons. When they share with each other, each of the nitrogen atoms gains 3 more electrons. We can see that there are a total of 2 lone pairs and 3 bonding pairs of electrons. Here is a fun fact. Hydrogen is a unique type of element. Common noble gas of every element has 8 electrons, but hydrogen can only fit in 2 electrons to form a noble gas of hydrogen. For example, hydrogen fluoride. By using single bond, each of them have their kind of noble gas, even though they don't have the same number of electrons. So hydrogen fluoride has a total of 3 lone pairs and 1 bonding pair of electrons. Bond strength can be explained in chemistry as the strength with which a chemical bond holds into 2 atoms together. This is conventionally measured in terms of the amount of energy in calories per mole required to break the bond, while bond length is the equilibrium distance between the nuclei of 2 groups of atoms that are bonded to each other. So we can conclude that single bond is the weakest yet longest bond. Double bond is neither the longest nor the strongest bond, but it is also not the shortest nor the weakest, while triple bond is the shortest and strongest bond. Electronegativity of an element is a measure of the tendency of an atom to attract a bonding pair of electrons. Electronegativity values are useful in determining if bond is to be classified as a non-polar covalent, polar covalent, or ionic. So this is the table for electronegativity. So there are 3 types of bond types as we know. Ionic has an electronegativity of more than 1.8, nonpolar has 0 electronegativity, while polar has 0 until 1.8 electronegativity. There are much more things that we need to do to discover about covalent bond. As I had mentioned before, Lewis structure is 2-dimensional and it gives us no idea about its shape. In this topic, we will talk about VSEPR theory. VSEPR stands for valence shell electron pair repulsion. This tells us the 3-dimensional shape of the bonding. The electrons repel as far as they can in space. Electrons can meet with electrons as they repel and can stick to one another. The point is that lone pair is stronger than bond pair and it needs wider angle compared to bond pair. This decreases the angle of the bond pair. For example, sulfuric oxide. Sulfuric oxide has 4 bond pairs and 1 lone pair. One lone pair consists of 2 electrons. The angle for the bond pairs are less than 120 degrees, roughly around 118 degrees. This molecular geometry is called fan-shaped because its shape is like a V. Tetrahedral varies. When it has 1 lone pair, then it will be called trigonal pyramidal as it has this kind of shape and 107 degrees angle. If it has 2 lone pairs, then the angle will be around 104.5 degrees and its shape will be fan-shaped. Now let's discuss about molecular polarity. There are 2 types of molecules, polar and not polar. Here is an example that shows the difference between them. As we can see from the shape of the examples, polar is symmetrical while non-polar is asymmetrical. The next topic will be intermolecular force. During this topic, we will be discussing about 3 types of intermolecular force attractions. The weakest attraction force is London forces. Every molecules have London force. This term can be explained easier if you know what happens to a non-polar molecule such as diatomic hydrogen H2. When it is being approached by other hydrogen molecule, there are 3 factors that affect the magnitude of London forces: number of electrons, size of electron cloud, and shape of molecules. The greater the number of electrons, the larger the distance between the valence electrons and the nucleus. The attraction of the valence electrons to the nucleus will be reduced, and hence the electron cloud can be polarized more easily. The smaller the volume, the more attraction of the electrons. Dipole-dipole is the second strongest intermolecular force attraction. It exists in all polar molecules. There is an attraction between the positive end of one permanent dipole and the negative end of another permanent dipole on an adjacent molecule. Hydrogen bonding is the strongest attraction. It needs high energy to break them apart. Hydrogen bonding only appears when the molecules are connected with nitrogen, oxygen, and fluorine. We will be discussing about metallic bonding. This is the last subtopic in chemical bonding and structures. Metallic bonding is the electrostatic attraction between a lattice of positive ions, cation, and the localized electrons. The strength of metallic bond depends on the number of valence electrons that become delocalized. the charge of the metal ion and the ionic radius of the metallic positive ion's cation. Alloys can be defined as a metallic material, homogeneous on a macroscopic scale, consisting of two or more elements so combined that they can be readily separated by mechanical means. Cast iron is one of the examples of alloys as it contains of metal ions and non-metal carbons. Compared to the parent metallic element, alloys have greater strength, enchanted magnetic properties, and greater ductility. So this is the end of our video. We really hope that you understand chemical bonding and structure like we do. Thank you for watching.